Hello everyone, this is your instructor Sir Adam again, and in this video we are going to be covering angle properties of circle. The first property that we are going to be looking at is the angle at the center of the circle, which is this angle, is twice the angle formed at the circumference of a circle. So if this angle, let's say, is 100, then the angle at the circumference must be half of it, that is going to be 50 degree. Let's look at a applet to further understand. If I have set the angle AOB to 100 degrees, and if I change this slider, do you notice that as soon as I'm changing the position of point C, the angle BCA does not change. The angle BCA represents the angle at the circumference. Since the angle at the center BOA is 100, the angle BCA is going to be 50 degree. Okay. Alright. Now, the other diagram could be this, where that's your angle at the center and this is your angle at the circumference. So if you are given that angle AOB is 100 degrees, then the reflex angle AOB is going to be the angle at the center of the circle, that is going to be 360 minus 100, 260 degrees. Angle at the center is going to be twice the angle at the circumference. So angle at the circumference is half the angle at the center. So that's going to be 260 upon 2, 130 degree. Now over here you can see various variations of this property. If AOB is a diameter, then the angle at the center is 180. Angle at the circumference is going to be 90 degree. If you take AB as a chord, then AOB is angle at the center and APB is angle at the circumference. So if this angle is 30 degree, this angle is going to be 15 degrees. The angle at the circumference is always going to be half of the angle at the center. Okay, consider AB as a chord in this diagram. If this angle is, let's say, 20 degrees, then angle APB is going to be 10 degrees, half of the angle at the circumference. Let's look at an example question. The diagram shows a circle center O. Try to understand the diagram first. Let's say this is point A and this is point B. Okay, there is an imaginary chord AB. Let me make this chord AB. Now, this is over here, this angle of 58 is the angle at the circumference. Then what is going to be the angle at the center? So AOB, which is the angle at the center, is going to be twice the angle at the circumference. So 2 times of 58, that is 116 degrees. Now, since we want to find angle Z is going to be 360 minus 116 degrees, because angle about a point is 360. So that is going to be 360 minus 116, that comes out to be 244. Let's look at another example. A, B and C points are on the circle center O. Find the obtuse angle AOC. So we need to find this angle. If you remember, this angle ABC given to you is 130 degree, which is the angle at the circumference. Recall the property that says that angle at the center is going to be twice the angle at the circumference. So the reflex angle AOC is going to be 2 times 130, that is 260 degrees, and the obtuse angle AOC is going to be 360 minus 260 degrees. Okay, that is going to be 100 degrees. Alright, that's how you apply this property. Now the second property is angle in a semicircle is always going to be 90 degree. This line AOB passes through the origin O. It's a straight line called the diameter. Now what a diameter does is it divides the circle into 2 semicircles. The property says that if you are going to have angle in a semicircle, that is always going to be 90 degree. What does that mean? That means that if I have, let's consider angle AZB, This is the angle formed in the semicircle, so it should be 90 degree. No matter wherever this point Z can move, that's going to be 90 degree. Okay, this angle is going to be 90 degree. Let's have a triangle AQB. So this is going to be a right angle triangle. At the right angle is going to be at point Q, because that is the angle in a semicircle. Similarly, angle ARB is also going to be 90 degree. Okay, so try watching this. If I keep on moving point D anywhere in this semicircle or in the semicircle below, you can see that even I am changing my point B over here, the angle is not changing. That means the angle is always going to be 90 degree. So angle in a semicircle is always 90 degree. Okay, property number 3. What you see over here is a chord AB. If you are going to have an angle from this chord to the circumference of a circle, and you have another angle from the same chord to the circumference of a circle, the property says that since these are the angles in the same segment, remember, this chord divides the circle into two segments. If the angles are being formed in the same segment, then they must be equal. So this angle and this angle should be same. APB angle should be equal to AQB because angles in the same segment are equal. Okay, consider AB as a chord. If I try changing point D and point C, do you notice that angle, because these are the angles in the same segment, then the angle value is 30 degree. ADB is also 30 and angle ACB is also 30 degree, because the property says that angle in the same segment are equal. The next property is angle in the opposite segments are supplementary. What do we mean by supplementary? Supplementary means that the sum of the angles must add up to 180 degree. Now consider this chord. This chord is going to divide your circle into two segments. This is one segment and this is the other segment. These two angles are being formed in the opposite segment by the same chord. So these two angles must be supplementary. For example, if this is angle A and this is angle B, so A plus B must add up to 180 degree. For example, if this is 30 degree, if this angle is 30 degree, then angle AQB is going to be 180 minus 30 degree, that is 150 degree. Angles in the opposite segments are supplementary, meaning that the sum of these two angles must add up to 180 degree. Okay, try watching over here. Consider BC as a chord. If you see that point A and angle D adds up to 180 degree. 103 plus 77 adds up to 180 degree. So this angle BDC and angle BAC are the angles in the opposite segment. They are always going to be supplementary, which means that the sum must add up to 180 degree. Okay, let's look at how to apply these properties. In the cyclic quadrilateral PQRS. Now what is a cyclic quadrilateral? Cyclic quadrilateral is a quadrilateral whose vertices are all on the circumference. So PQRS is a quadrilateral whose all vertices are on the circumference of a circle. So the question says that angle SPQ, this angle is 78. You need to write down the geometrical reason why angle QRS is going to be 102 degree. QRS is this angle. Okay. Now if you are going to consider SQ as your chord, then the angle SPQ and SRQ are the angles in the alternate segment and they must add up to 180. So if this angle is 78, this angle SRQ is going to be 180 minus 78 degree, that is 102 degrees. This is why the angle QRS or SRQ is going to be 102 degree, because these two angles are the angles in the opposite segment. Remember the property, angles in opposite segment are supplementary. Okay, then you have been given that angle PRQ and angle PRS. PRQ is this angle and PRS is this angle. They are in the ratio of 1:2. So if you want to evaluate this angle, it's going to be 1/3 of 102, and this angle is going to be 2/3 of 102 degrees. So if you do the maths, this angle is going to be 34 degree, and this angle is going to be 68 degrees. Okay, you need to calculate the angle PQS. PQS is this angle. Now try taking PS as your chord. Have a closer look on the diagram. If you take PS as your chord, then from this chord there are two angles being made on the circumference of the circumference, and these are the angles in the same segment. So if this angle, we want to find this angle, the value of this angle is going to be equal to this angle, which turns out to be 68. So if this angle is 68, this angle is also going to be 68. Why? Because angles in the same segment are equal. And the last angle property is that the angle between the tangent and the chord. So this is the tangent line. There's a tangent line to the circle at point A. AB is a chord in a circle. The property says that the angle between the tangent and the chord, which is x degree, is going to be equal to the angle subtended by the chord in the alternate segment. And the angle in the alternate segment is ACB. That should have a same value of x degrees, because angle between the tangent and the chord was x degree in the alternate segment. So angle formed by the chord in the alternate segment should also be x. Consider this example again. This is your tangent line. AC is your chord. So the angle between the chord and the tangent is y. So this angle is going to be equal to the angle formed by the chord in the alternate segment, that is y. So that's why this angle is y. Okay. Let's take the values. If this is 30 degrees, then this angle should also be 30 degrees. If this is 70 degree, then this angle should also be 70 degree. Okay. Let's try to do this question. PQRS are points on a circle and PS is equal to SQ. So this tells that PSQ is a isosceles triangle. PR is the diameter. So they have told you that PR is the diameter of the circle. TPU is tangent to the circle at P, and angle SPT is 63. That is the angle between the tangent and the chord. So that is my chord PS. TP is the tangent. The angle is 63. So this angle is going to be equal to the angle formed by the chord in the alternate segment. So I can mark 63 over here as well. If this angle is 63, because these two lengths are equal, this makes PSQ triangle an isosceles triangle. So this complete angle is also going to be 63. So to calculate the value of y is going to be equal to 180 minus 2 times 63. That comes out to be 54 degrees. So y is 54. Now, how do we find the value of x? If you take PS as your chord, then from this chord there are two angles at the circumference. Since these two angles are angles in the same segment, the value of these two angles must be the same. So this angle must be equal to 63 because angles in the same segment are equal. Okay, these were the 5 properties. I hope this video was helpful for you. If you like the video, please share it with your friends, like it. Thank you.